Okay, so I'm Owain, I work at Just Eat. I'm a newbie at Just Eat, I've only been there 5-6 weeks. And I got invited to come and talk about some of the stuff I've been doing in the whole 5 or 6 weeks that I've been there. And really, this is a bit of an odd talk because there's no big reveal at the end. I'm not going to demo anything or go da-da. This is actually more of a question to the audience about, you know, what is the next generation of monitoring. So Just Eat, I've got to read these numbers myself because I haven't memorized them. We have 80 million customers. We do about 45 transactions a second at peak time, sometimes in excess of that. Do about 500 releases a week, and more than 1,000 AWS instances, and we grow, and this is an important point, we're kind of growing all the time, which has interesting implications on metrics. So what do we have at the moment? So Just Eat has a pretty mature use of ELK and time series stuff. They've been doing it for 4+ years. All the developers go on call, so they're in and out of graphs, they're in and out of the ELK stack all the time. It's a much more mature use than I've kind of anywhere else I've worked. They use StatSD a lot, Grafana as a front end, and then they do a lot of the alerting off the time series. And really the question that's been asked is, okay, so that was what they built 4 years ago. It's 4 years later. Then it was kind of reasonably, not cutting edge, but you know, at the beginning of that curve of kind of everyone doing it. Really, what's now? What's cutting edge now? What's new, exciting? And really, we've been trying to investigate that. So what is it that Just Eat need from their monitoring and alerting stack? Well, ultimately, they're trying to get an on-call engineer to the root of the problem as quickly as possible. So, you know, outages cost money. That's shock horror. Who knew? But there's obviously, you know, quite a lot of alert noise, and it's really about trying to fine-tune mean time to recovery through the mechanism of, you know, better visibility. So we've been through a process of requirements gathering. So we've gone out to the whole organisation and gone, hey, you know, if there's anything you want from monitoring, having been doing it for the last 4 years, you know, what is it you need? And something that kind of cropped up in the kind of InfoSec world is really GDPR. So at some point, someone will write a log entry like this, you know, taking some kind of customer object and putting it into your logs, and therefore it's indexed. And with the GDPR rules, you've got customer name, you might have email address, you can, you know, you've got all of the personal information in there. Suddenly, it's still legally tenuous as to where this whole sits, but do you want to be on the wrong side of that? So, you know, essentially you've got indexed personal information that, or at least you should assume that you've got indexed personal information. And the same with PCI data. You know, you don't know what a payment service provider is going to return you. You kind of assume that they're not dumb, but apparently they do return you silly things like 2CV codes every now and again. And then as a result of having this stuff, you start needing to talk about role-based access control. Who can access this stuff in a PLC? You know, accessing time series data around some metrics can be commercially sensitive. You need to start thinking about controlling that. And obviously, you know, with Kibana and I suppose to some extent Grafana and so on, you know, essentially, if you've got access to this stuff, you can see everything. We're starting to understand that maybe we don't have the same flexibility that we've had over the years. And then similarly, if there's PII data in here, can we export that data to another region? So if we've got servers in Australia, we're not allowed to export that personal data out of Australia. So suddenly multi-region data replication starts to become an interesting concept. You know, we can't just sort of centralize all our time series and logs in one location. So we've also understood that actually we've got a bit more scope. So we started talking to other parts of the business, and our whole networking guys were like, "Hey, yeah, great. We want some more of this stuff. Can we have all the flow logs from AWS? Can we start throwing in lots of the routing, the router data that sort of peers up different AWS regions and so on?" So that suddenly kind of increased massively the scope and the quantity of data that we could be looking at. And then in our world as well is multiple regions, and so far we've sort of had some centralized Logstash instances, which has been unpopular with the guys in Australia, with a 300 millisecond latency sort of in each direction, and the sort of query times are particularly slow. So as a sort of providing a service to our internal customers, that's pretty rubbish. So it's kind of lends itself towards needing to think about storing this data geo-local. But then interestingly, if we've got a first-line support team who are working out of hours in one region, say London, but they're looking at the system in Australia, then we've just reversed the problem. So actually, are we starting to look at needing to store this data in two places, ignoring the GDPR rule, or finding the balance between the two? So that's kind of made us scratch our heads a bit more. And then something else that's kind of starting to become a bit more apparent as well is that we're starting to add more layers of abstraction. So if you start looking down the kind of service mesh route, well, there's a whole bunch of new logs you need to have. Again, AWS flow logs, I mean, they came out about a year ago. Actually harvesting those, there's quite a lot of interesting information that can come out of those. Start moving into the containers world. Okay, now we've just increased the potential quantity of logs, especially if we start decomposing our stuff into smaller and smaller microservices, on top of the bog standard OS logs and so on. So we started pondering on kind of what do log events look like? Well, no surprise, I'm sure everyone's sort of seen log messages that look a bit like this, essentially JSON events. With clustered with some additional metadata, and I'll come back to that in a second. So we've been using Graphite, and the time series potential inside Graphite is pretty noddy. So you've essentially you're describing your metric as a single string, so it's CPU1 from node 01, etc. But the guys are really wanting to be able to try and find out to run queries that are specifically asking, give me all the CPUs from the box in cluster 1 that's only in AZ1, because I only care about those, I don't care about the rest. And that starts you to lead thinking about needing to tag the time series data with additional metadata. So what do time series events look like? Oh, hang on. Aren't they the same as log events? The only difference between being message versus value. Ultimately, you've still got this supporting metadata. That was an interesting thing that we started to ponder on. So one of the other things that the developers talked about was realizing that our 10-second resolution was hiding interesting information. One specific example is DynamoDB throttling. So we use a fair amount of DynamoDB in some of our applications, and they would actually miss whole throttling occurrences because the time slices between the metrics collection wasn't sufficient. So they were starting to say, well, hey, you know what, it'd be great if we could have a short window, 72 hours, so we can cover a weekend of 1 second resolution. It's like, whoa, okay, that's quite a lot of data. And then the same with application logs. So being able to log at debug potentially means that they're able to track down the specifics of a problem really quickly, because actually they've got more verbose logging And what if they could, again, keep a 72-hour window of that kind of stuff? And that's like, well, is this what next gen is like? Is it dialing up resolution? Don't know, not sure. If you go down that route, then you start to think, well, actually, hang on, do we need to shard this stuff, right? We can't have like this Uber time series database that can manage 1 second resolution for 76 hours and the last 3-year history on, n million metrics. Inevitably, you're going to need to shard. The same with Elasticsearch. It's not infinitely scalable. At some point, you're going to have to scale it out. So it seems like, having to embrace sharding at some point in the journey is inevitable. So then starting to look at these kind of JSON events, whether they're time series or log events, it starts to make us wonder, is it a stream? So are we actually talking about these streams of events? And if it is a stream, can we start thinking about consuming these streams with different consumers who are actually subscribing to the events they're interested in, which then allows you to start supporting interesting possible sharding models, or even pumping stuff into Hadoop, or sending specific logs to the InfoSec's SIEM databases, pumping some of them out to third parties. Maybe we don't want to have to deal with all our time series data. Maybe we just push this stuff that's slightly less interesting, or we look after the high-res stuff. We pump out the third-party stuff elsewhere. This started giving us an interesting perspective of perhaps putting pub/sub as a model for this data could perhaps leverage a lot of benefit. There we go, preempted that slide. The other benefit of perhaps looking at a pub/sub model is we could actually plug in and out different technologies as we see fit, and without any coupling. So, at the moment, we're kind of routing stuff over TCP in a specific protocol to statsd, which then spits it out in a specific protocol to graphite. With a stream, it's kind of, you've suddenly made it a bit more abstract and a bit more generic. And, you can apply filtering and so on. And then even, subscribe to the stream, make some calculations, republish it to be stored elsewhere. Or even potentially, we know, so we have about 650 odd dashboards, maybe 1,000, something like that. Could you actually, you know exactly what graphs you're going to be building. Could you pre-render them and never actually hit the time series data for those dashboards, and only go into the time series data when you want to change the resolution or the time range or what have you? And would that give you the benefit of sending out a link, putting a link into HipChat during an incident? Suddenly 50 people are all trying to open up the dashboard, and then suddenly the time series database is under a lot of strain. Would that kind of remove those kinds of problems? Which then made us wonder, actually, is this multiple streams? So then you can start thinking about, well, if you're in a multi-region scenario, can you actually glue the streams together or do a bit of replication? And then you can start heading towards the idea of active monitoring, or you take some off-the-shelf time series databases, and rather than trying to make them a highly available cluster, you run 2 or 3 of them as singletons, maybe in one region or as a pair of regions, and they're just subscribing to the stream. So you end up with 2 copies of the same data, but that gives you some high availability, but without all the headaches of trying to do clustering. And then obviously, because you've got all this metadata around, it allows you to do kind of subscriptions of, I've got an elk stack dedicated to high resolution stuff, then, or, I will just pull in stuff that's, got log level debug, whereas another elk stack could just be looking for log level info and error and so on. Or if you want to send stuff to just InfoSec, you could do it by security log or what have you. So something else we talked about is anomaly detection. And this seems hard, right? There are lots of different types of algorithms, as probably everyone knows, supervised versus unsupervised. It seems like for the kind of metrics we have, where we've got this growth, a lot of the unsupervised algorithms struggle a little bit. So it would definitely lean us towards supervised. But obviously, again, with this streaming model, you'd be able to potentially apply different algorithms in parallel if you wanted to test them out. Also, could you potentially do forecasting by shoving a load of this stuff into Hadoop and looking for future failures and so on? I don't know. Is this next gen stuff? Is anomaly detection the next generation? It looks quite involved as a thing to do yourself, but maybe this is what the cutting edge is. And then there's tracing, right? So maybe instrumenting the code might be a better approach. Actually, kind of getting an understanding of how the code is working and where the latencies are, and so on. Would that improve the developer's ability to visualize where the problem lies? I mean, there's a few tools. There aren't many tools in this space. And obviously, there's a massive development commitment in order to support that. Because essentially they have to dive into the code and write lots of lines to add traceling. But if you do embrace this, does this actually change the use case for time series and logs? Does that suddenly become less relevant? And actually focusing time into tracing, remove a lot of the headaches needed to handle these large data volumes, because they have the granularity of information they need from the actual executing code. Again, maybe is this the next generation? So really, all this talk was maybe selfishly on my part, asking you guys, is anyone on this journey? Has anyone already done this? And secretly going, yeah, we've solved all these problems. If so, let me know. But maybe this is also like, why don't you stand up here and talk about it? Because I would certainly benefit from understanding what people are doing in this space, because it's not 100% obvious to me. I mean, the other thing, you might be sitting there going, well, if you Google this, you'll find this whole world of information. Maybe I don't know the right Google queries. So let's talk. Talk to me afterwards. I'll be really interested in understanding your thoughts and opinions. I'll definitely go for a beer afterwards and talk about this stuff for hours. That's how to get up and get in touch with me. Thank you very much.